In order to share the idea, I brought back this problem that we just did of the 16 horses in the Kentucky Derby. So I want to take a different look at this. So here we had a 16 times 15 times 14. And in order to get the possible results, we just multiplied the three of them together. Now let's suppose that we didn't know that. Let's say that we didn't know how to calculate 16 times 15 times 14, but we did have an understanding of what a factorial is. So here, let's suppose that we continue this pattern. In order to create 16 factorial, I would have to multiply all of these integers all the way until we get to 1. So here, let me get rid of this part here. So that would be 16 factorial. But the thing is that we only cared about the first three positions right there. Right? So we have a lot of integers that are not really useful. However, let's say that we divide the whole thing by the 13 times 12 all the way until we get to 1. So now what I did here, if you notice, is I divided by everything that I added. And if I divide by the same thing that I added, then this does not change the value of the expression. It's technically I'm multiplying by 1. Now, the reason I want to do this is because we want to familiarize ourselves with things that we already know. So here in the numerator, I can reduce this to just 16 factorial. And in the denominator, I can reduce this to 13 factorial. And now, if we had an understanding of factorials, we could calculate this problem using this notation or this expression. Let me take this one step further. In the problem, we have three different events, first, second, and third. So here I could rewrite this as 16 factorial divided by the 16 minus the 3 events that we were trying to pick. And you can notice that 16 minus 3, that's going to give us 13 factorial. So we can rewrite this expression as such. So here I really broke down the pattern. And now this pattern is what we want to generalize and attach an algebraic equation to this. So the generalization is this one right here. The number of n objects taken k at a time can be represented algebraically using the formula npk. This is going to equal n factorial divided by n minus k factorial. This is going to give you the total number of permutations possible. So let's try a couple examples just using this formula so you're comfortable with the notation. So here's example 1. Let's compute 7p5. So I'm going to rewrite my skeleton here. And my skeleton is the generic formula. So npk is going to equal n factorial divided by n minus k factorial. So now here 7 is my n and 5 is going to be my k. So I'm going to substitute this in. So 7p5 is going to equal 7 factorial over 7 minus 5 factorial. And this is going to give me 7 factorial. We do the parentheses first. So 7 minus 5 is going to give us a total of 2 factorial. And now here we can put this into a calculator, 7 factorial over 2 factorial. So please watch that video on how to get the factorial on your calculator. So here we're going to get 2,520 possible outcomes. Now, if you don't want to use the calculator, what you could do here is expand the numerator. So here, my numerator, I'm going to expand it up until the factorial that I have on the bottom. So here's what I mean. So we have a 7 times 6 times 5 times 4 times 3 times 2, and here I'm going to end the factorial there, divided by 2 factorial. Now I have something on the top that's similar to something on the bottom, so we can cancel those out. And here I'm left with the 7 times 6 times 5 times 4 times 3, which is what you would have gotten if you would have taken the placeholder route. If this was a word problem, you could have done the placeholder route, and this is what you would have gotten. And then just multiply these together, and you're going to get 2,520. Let's do one more. So here we got to compute pt3. So again, let's write the generic formula. Here I have npk, and that's equal to n factorial all over n minus k factorial. So n, that's my 8, k, that's my 3. So for 8 p3, we're going to get 8 factorial over 8 minus 3 factorial. And we do the parentheses first, so 8 minus 3, that's going to give us a 5, and then we have a factorial on the bottom. So let's simplify this part right here. So we're going to get 8 times 7 times 6 times, we're going to stop at 5 factorial because that's what we have in the denominator. And we're doing this strategically so that this cancels out. So we get rid of the 5 factorials, and now we have 8 times 7 times 6. And 8 times 7 times 6 is going to equal 336. So we have 336 possible permutations. Alright, so please get started on the next set of problems, and I'll see you back on the next video.